Hello, everyone. Konnichiwa, konbanwa. Konbanwa kana. Let's start the presentation. Let's talk a bit about the presentation. I'm going to present a tool called CIRCO. CIRCO, whatever you want to pronounce it. It's a network implant designed for Cisco, and we'll go into details. This is what you see just here before the start. I need to simulate the network infrastructure. So this is actually a network in a box, in a way. Firewall, switches, PoE, DNS, DHCP, internet as well. So you will see that little blue box is my internet server. There's also a phone connected in the network, like you will see in any other network, an IP phone, PoE. So this is currently how it is set up. So let me start the presentation. First, my name, konbanwa. I'm Emilio or Emilio. Both ways works. I like to play with packets a lot, electronics and 3D printers, just for fun. I did present a couple of tools in the various conference, this one and another tools, and I'm not a native programmer, neither a Japanese speaker, but ganbarimasu. All right, this is version 1.5 of the tool. So what is new in this version is that now we allow to integrate the phone and the implant at the same time. In versions before, once you use that, the phone will stop working. Also, we craft all packets with the native SCAPI, and we add another exfiltration technique through NTP protocol. We also add Bluetooth encryption for preventing forensic, and a self-destroy switch. We bypass NAC now, so NAC will not find us anymore. And any credentials integration into Faraday, which is a different tool, right? So this is the persons that we look to target. Mainly our automation systems, like I just named a few of them. They all work very similar. The concept is when you plug a new switch into the network, the automation, so they will discover the new switch and connect to it to pull inventory, configurations. So this is how automation works in many enterprise. So these are an example of the tools you probably know. NAC, for example, is a network access control, and the idea is to prevent you connecting like a Raspberry Pi or a laptop that is not part of the company. And of course, you can manually also connect to the device, the fake switch that we want to implement. The evolution, how this all started, right? Let me talk with memory lane. So we started a year ago with demo box, version 1, which was literally built on a cardboard box with tied up pipes, and it was a POC, and it actually worked fine. And then we moved into version 1.4, it was a jump thing, and we managed to put the components inside a network outlet. So they look like this. You probably saw them under your desk in companies, or maybe like these boxes, you see? So what I managed to do is inside these boxes to put electronics on it. And the problem we have in version 4 was a PoE problem, because I can take the PoE from the phone, but the phone will not work anymore. So that was a problem with version 4. As you can see, only one cable can connect at a time. Now, in version 1.5, which is the latest version I'm going to show, you are able to keep the phone working and use the network implant at the same time. So how this is all built is, well, there's a hardware component, I will go into details, and there's a software component. The components we have is basically 3 main components. One is our software component in the internet, VPS maybe, just Python software, which is this blue box here, which is a VPS in Amazon or Sakura VPS, a public internet server that runs on software only. So then we have the CIRCO itself, which is the hardware component. It's designed you to go to a company in a meeting room, in a reception area, wherever it's an IP phone. That's why you want an empty desk. So this is what I want to do. I want to put this box here. Why the phone? Because the phones run on PoE, so I need the PoE to power up this. This doesn't run on batteries. There's no battery here. And there's one more component called Howler, which is, again, software component, and it's designed for exfiltration technique via wireless. It's made in Python 2, and is currently under Python 3 ongoing migration. And it's basically, this behaves as a honeypot. So it will actually trick your automation systems into believe there's a new Cisco switch in the network. They will connect to me. They will give me the credentials they use for all network because they're automation systems. And once I get that data, user and passwords, I will exfiltrate to CARPA, which is in the internet. So it's a combination of a honeypot pretending to be a Cisco switch and exfiltration techniques. And we go into the details. But just to give you an overview, the kind of exfiltration techniques we use, there are ICMP, traceroute, NTP, HTTP, HTTPS, DNS, proxy, and wireless. Those are currently the ones that this box is supported. So you can choose which one you want, or all of them. And there's an extra thing going on that because sometimes you plug a PC to a phone, it's common in the companies to save cabling. So now what happens is I can also get all the credentials from the PC going to the network as well. So that is coming on a different release, just to mention it. At any time you can ask questions. Right, what is the honeypot we create? Well, we need to pretend to be a Cisco switch. So CDP need to be able to communicate CDP and LDP. You need to be SNMP, responsible. You need to respond like a Cisco switch SNMP. You need to have a telnet interface. You need to have a iOS commands. You need to have an SSH interface. And also, when NAC found this new switch, NAC will actually do fingerprint, OS fingerprint, and service fingerprint. And those need to reply back as a Cisco switch. Remember, if not, NAC will block us, realizing it's not the Cisco switch. So this is a high-level overview because everyone wants to see the demo, right? Me too. Okay, let's see. Demo time. Right, before we go into the demo, I will show the lab, just to give you an idea where we're standing. So this is a phone called Victim. This is the infrastructure itself. There's a real switch, Cisco switch, and a called switch Tokyo 01. There's an actually PoE injector to provide, and there's an internet, DHCP, etc., and my internet server is a blue box, which is a Raspberry Pi, but it could be any software running Python. I also have a snort, but unfortunately I don't really see anything in a snort anymore. So let's go deep into the demo. All right, so first of all, on the bottom, this is my internet called CARPA, blue box in the internet. So when I run data, the options I can configure. At the moment, we can set it up with, let's say, the verbose mode will actually display the credentials that he received. This is the box that will receive the credentials from this box. Also, we have the integration into Faraday, which is a vulnerability management and pen testing tool, this is how it looks. And within Faraday, there is something called credentials, which currently there's no credentials. You can manually add or through API credentials. This is for vulnerability and pen tested reporting. So we will integrate with Faraday. And also, I need to specify my interface, Internet 0, and which is the destination file, like, I don't know, cred.txt. I don't know. Just a file where the output will go. But we put verbose, so we will display in the screen as well. So once you start this on the internet, it gives you an error. Give me a second. Yeah, the credential will not work because I'm not connected at home. The server is not here, so let me remove the integration. Right, so now, on the other hand, now it's listening, right? So now on the other hand, I have the box. So what I'm going to do is I need an extra cable, right? The box has a phone and a LAN cables. So I'm going to unplug the phone and put this box in the middle. And we want to put the phone back, right? If I say phone, just plug the phone back. Right, so the box is designed to run by itself if you want to, but because it's a demo, you want to see how it runs, I can actually will access manually. So first of all, let me go to the actual real Cisco switch. It's called switch Tokyo 01. If I do show CDP neighbors, it's a command, I see no neighbors, nothing connected to the switch so far, or at least it speaks CDP. Or LLDP. Well, now I can start to see a phone actually through LLDP. So let me go to the box. So now I'm in the actual box. I have a backend SSH management via wireless, just for demo purposes. But this is the menu you get, I spoke before. So we will put it verbose, so you can see what it's doing. Also, we put a bridge mode. Bridge mode is the new version 1.5, which allow me to have the phone and the box in the middle. If you want to go back to just one device, not phone anymore, you can put in single mode. Also, I can specify which exfiltration protocols or technique I want to do. So I can select ping, I can select, I don't know, NTP, I can select proxy. No, you can select all of it if you want to. I will go into details. So let's start to run it. Probably may work, may not, let's see. So these are the steps when you put verbose. It will tell you what it's doing. What the first thing this box will do is to change the MAC address to a Cisco MAC address before actually starting the interface. It will configure a bridge interface to bridge the phones with the networks. So it's basically Ethernet 0 and Ethernet 1 bridged. So it will also start to do a discovery phase to see what is the device name that is close by, where I'm connected. In this case, Tokyo Switch 01. Why I'm doing discovery is to pick up a similar name. So based on the name that I found through CDP and LLDP, I will put myself a name similar. If I don't find that, I can always go to switch 01, test, or whatever you want to put it. Also, we get an IP address, configure, ARPS, gateway. It will try to do, because I select proxy for exfiltration technique, there's 3 ways to exfiltrate proxy. One is WPAT, the other is DHCP option 252, and the other one is guessing. DNS guessing. We'll go into details there, but you see that I found actually a proxy file in this URL through option 252 DHCP. Change the names and everything. So now if I go to, I'm the real switch, 01. So if I do show CDP, I actually see a phone connected and actually a switch called 03. If I do show CDP neighbor details, I can see that there is a switch called 03 with an IP address 151. This is the capability and the model. This is the version, etc., etc. Okay, there's an IP address, right? If I do show LLDP neighbors details, I can also see a similar thing, right? But through the different protocol. You can see a switch 03 and an IP address. It's 151. Here you go. Right. So now I'm going to leave the real switch. Tango is the automation system or the administrator PC. So what happens if I telnet that box 151? I get the same prompt as the one, and I can put, I don't know, code blue and a password. Actually, you can put any user or any password. That's a great thing of a honeypot. So everything's okay. And I get a prompt like a Cisco switch. So if I do show version, okay, that gives me the version of the Cisco switch. Show interface description. These are all Cisco commands. Show IP ARP. Show all these address. Show IP route maybe as well. So all these are Cisco commands that automation system automatically will try to get show inventory. Maybe. Inventory. Yeah, I get the description. Now, so as you can see on the bottom of the screen, because I select ping and I think it was DNS and proxy or something like that, you will see on the bottom of the screen that the credentials that I just typed already start to be exfiltrated. The T stands for telnet, the username and the password, and the source IP internal of the actual PC or automation system that connect to me. The IP external is the one that the firewall is nothing to go to the internet. Or not in the proxy or not in whatever. So you will see that this PDNS, which is proxy DNS, exfiltration technique, ping, NTP, and this is get repeated in a cycle. So you can tune how often you want to send it, or one off, or send it every 10 minutes or 15 minutes. All the timers can get tuned. So what happens if I do enable? And I put another password. I get in enable mode, right? However, if I want to configure the switch, I'm not allowed to. However, I can do a show run, and I can get the configuration. And this configuration is dynamically created. So for example, in the configuration, you will see the username is exactly the same one as just type. So this is via telnet, all right? What about if I SSH? Via telnet or SSH work exactly the same commands are allowed. I can also do show CDP neighbors from the fake switch, and I can see the real switch, like exactly as Cisco will be. They can see each other. Same with the LDP. So they can see each other, right? Same concept. The only difference is when now you see in the bottom they say T and E and then say hola. That means that the E stands for enable. When I type the enable password via telnet, that is the way to exfiltrate. So the hola is the password that I just typed for the enable mode access. When you use this through SSH, instead the T, you will see an S here with the user and password, whatever you use, right? So, okay, so telnet and SSH and CDP and LDP, they all pretend to be a Cisco switch. What about SNMP? Just have a random community. And I did something wrong. So when I type a random community, it doesn't respond. However, that community you can see that is going to get exfiltrated. So even that you put the community that you use in your network, automation systems what tend to do is they use the community that you use in your company, maybe a few communities, and then if they cannot no response, they will try with the default, which is public, right? Just in case. I just got it. So if I try public, I actually get that is the name, the version, the uptimes, and all the information like a Cisco switch SNMP walk will reply. As you can see on the bottom, the P stands for SNMP, and this is a community, even that it did not work, actually I still exfiltrated because it's a valid community that you use in your network. So, so closing this with SNMP, Telnet, and SSH, and CDP, and LLDP, it all pretend that it's a Cisco switch. However, what about NAC? NAC, the way that works, NAC has a filtering by MAC address. Some MAC address, for example, they are like fonts are generic ranges open, but when it's very difficult to filter, to have an inventory of all the MAC address and keep updated of everyone in your network, because you have TVs, fridges, you have readers, so it's too much, and they get swapped, phones get swapped. So what MAC does is they may quarantine it, and they will do fingerprinting. How NAC does fingerprinting? Well, they didn't reinvent the wheel. They just use a tool called Nmap. So what they do is they they do a service identification and OS fingerprinting. That's I'm pretty sure you're all familiar with this command. The SV is for service identification. Based on the service response of each telnet SSH or whatever daemon you have, they will try to classify which device is it. And the -O is in a TCP, UDP, ICMP fingerprinting. Based on the response of the OS kernels, or whatever box is running, they will know if it's a Windows, a Unix, or a Cisco. So this is something that NAC will do. So when NAC do that, if this is a valid switch, or it's a Raspberry Pi, or it's a valid device. So this is what NAC, or Nmap actually, report. You say there's two daemons, 23, 22 open. They actually Cisco's SSH daemon and Telnet Cisco daemon. This is running as 12.x iOS, and is designed to be OS detailed as a Cisco. Well, they give you various options, right? In this case, it's a Catalyst 2960. So if we can full Nmap, we can full SNMP, Telnet, SSH, LLDP, and CDP, there's no reason for any device to tell us that this is not the Cisco switch. So this is how it works, right? Now, one more thing. What about if someone finds this box and is a very smart guy and say, wait a minute, that box is not look like ours. And they open it, because that's a tricky thing. Now, if you do forensics, there's two things you do. First, you don't unplug the cables, because that's not the way to do forensic. You could. Now, what you're going to do is unscrew it, right? Remove the screws and see if, because this box looks suspicious actually, it wasn't a different style or something. So we will open the box to see what the hell this box is inside. So once you open the box, take the screw. Once you open this box, if you look at the screen, you will see here this little line. So once this box, there's actually a magnet switch here, that once you open the lid, as you can see that yellow thing is a magnet, and this is a magnet switch. So once you detect that someone, like in a Windows alarm at home, once you detect the lid was open, it will automatically shut down and reboot itself. You can self-destroy, turn it on fire, and also, actually, it will inform the last thing he does is send a beacon, say like, someone opened the case. So if you're doing a testing or assessment, okay, now it's time to tell the guys that I was you, actually. So the way that it works, one of the steps that, based on time, this work perfect. It's a Raspberry Pi inside, so you can get the SD card and do forensics. Well, not really, because the way that it works is, at the moment, this box will start up. It's looking for my phone. I have a Bluetooth service. You can create an app. What it does is you create just a service, a virtual service in Bluetooth, virtual device. You can enable it, and you can create an ID, right? UID. So when I put this box into the network, I have this on in my pocket. So when this box first boot, the first thing it does is look for this specific Bluetooth ID service, and the UID is 128 bits. And that is the encryption key for the actual partition. So once you take the power, and I'm not close by, or you open the case, and I'm not close by, this box, the hard drive is encrypted with looks. So even you get the SD card, you have a simple Debian, Raspberry with an encryption partition that you can't see really, unless you crack 128 bits of UID. So that's the reason, the two reasons why we want this magnetic switch. To turn off, to kill the box itself, and also to actually prevent forensics. So let me go back to the slides. So how the exfiltration work? As I mentioned before, these are the syntax format for the exfiltration. So we got the telnet enable. I'm sending username, password, and source IP. That's the three data I'm sending from this box to the internet. Same for SSH, for SNMP, actually the community and the source IP. And coming up soon will be the netcreds option. So these are how do I actually send packets from this box to the internet? Well, depend the protocol. For each protocol, remember I have around 15-20 bytes of encrypted with AES-256 credentials. Now, what I do, I split those 20 bytes into 2 bytes each, so I have 10 packets to send. So I will send 10 packets from this box to the internet, just one-way packet. This box in the internet has filters. It will never reply any packet. No TCP reset, no SMP, nothing. No DNS query, nothing. This box in the internet is dead from a point of view, so nothing comes back. So from a firewall point of view or IPS point of view, you always see timeout sessions. There's nothing established both ways. And you can tune how often you want to send those 10 packets. Maybe every 1 minute, every 6 minutes. You can put randomly. At the moment it's configured for randomly every 30 seconds. We say 1. So there's not really a pattern to follow. So for ICMP, which is ping, I'm using IP ID headers. In the IP header, I'm using the IP ID identification. Those 2 bytes, I'm putting there my chunk from the encryption. And also using ICMP sequence number. Again, 2 bytes, where I can use to put data on it. Similar for traceroute, I'm using IP ID, and I'm using the payload, the last four digits of the payload. For HTTP and HTTPS, and actually any TCP protocol, the way to exfiltrate data is I put in my 2 bytes, so I'm sending 10 TCP sync packets, just the sync, with using TCP window size, which is a 2 byte size. So I'm putting 2 bytes of my crypto, which is my passwords, my data to exfiltrate basically, using TCP window size. NTP, I'm using a stratum and different variables in NTP. DNS, DNS is the easiest one. You just query a simple DNS with your crypto.domain. However, remember DNS doesn't work, this box goes to the internet. It will go to your internal DNS. And your internal DNS will do an NS query type. Proxy. Proxy is interesting because most of the companies don't allow direct access to the internet. Maybe ping or traceroute for troubleshooting. Maybe DNS, but let's say that is a very kibishi. Doesn't allow anything, so if you browse the internet from internal company, you go through proxy only. Authenticate proxy. Okay? Sure. So for proxy, we have 3 different techniques. And also the wireless is using beacons. So that's to avoid whips to get detected. So just to put it into a diagram, this is how this, first of all, to send the information, I need to tell the receiver how long is the bytes that I'm sending. I'm sending 20 bytes. So I need to tell them you are expected to get 20. I'm also need to tell them the sequence. This is packet number 1, this is packet number 6, because they could arrive in a different order. So sequence numbers, byte length, and actually, so the first ping that I send contains that information, and the following, so I will send 11 packets, right? 10 with the crypto, but the first packet will be actually the first 1 or 2 packets will be actually the information of what you should be expecting, right? Traceroute, they all work similar, so I can go into details if you want to, but this is for UDP, so I have the process. I'm not sure you can see, probably yes. Yeah, it's quite big. I can see it. So you have this side will explain you what it's doing, and the receiver what it's doing. So this is as long as the firewall allows traceroute. For HTTP, HTTPS, to be honest, could be any TCP packet, any protocol, because I'm just sending a sync packet. There's nothing coming back, so there's no communication, so it's not even HTTP. But port 80 or 443 may be open from the internal network to the internet, maybe. NTP, this is a funny one, because NTP, there is a transmit timestamp field in the NTP protocol, which has 64 bits. That's nice, it's not the classic 32. So what I'm doing is the first 32 are actually the timestamps, and the next 32 bits are actually a fraction. So I'm hiding my 4 bytes in the last 32 bits, in the fraction. So you will see the timestamp correct, but the number on the fraction is what varies on the byte that I'm sending. Again, similar concept. I've used stratum and polum and precision just to tell first how many packets are you expecting, how long is the sequence, because there's padding sometimes. Let's say that I'm sending that 2 by 2 byte, but your crypto is 13. So I need to do padding, I need to do 14, so to send 7. So I also need to tell them, listen, I'm sending you 7 but realistically, you're expecting 13, so one must be padding, or that concept, right? And the sequence number. This is no 1, 2, 3, so you can assemble the other side. DNS. DNS is the one that is simplest, but this one does not require direct access from CIRCO to CARPA. It goes through your internal DNS or your DMZ DNS, right? So in this case, I'm using NS type query because NS gets forwarded to the chains of the actual root domain of the domain. So that guarantee that query, even that nothing reply back, it gets forwarded to the .com and then the blah.com and then my subdomain circo.blah.com, because it's an NS type of query, so it will get forwarded from the root down to the actual CARPA. CARPA, remembers, in the internet, it's public IP, and he owns the domain. He configured itself, registered as the NS record of that domain or subdomain. Proxy, this is where I get interested, because proxy, everything is closed, proxy is a one-way out. Problem with proxy is you need to find the proxy. So there's 2 methods, which is DHCP option 252, which give you a pack file URL for your PC to set it up, as Windows do that. Some companies put it there. So what I'm doing is I'm querying the DHCP server with DHCP inform to get that parameter, if it exists, right? Once I get something, I will go connect to that proxy file, get the pack file, parser to look for the proxy IP and port. Then I will connect to the proxy. And this is interesting because the proxy itself is, I don't know any company has an open proxy, to be honest. They're all authenticated. You need to authenticate Windows credential most likely. And the funny part here is that I don't have any credential for Windows, right? I got the network credentials, but definitely don't work in any proxy. So if I connect to the proxy and I do a get of my crypto.evil domain, the proxy itself will reply back with a 403, authentication required. And that's the end of the story. However, every commercial proxy out there, like big brands, big names, what they do is they will log an entry in the logs of the proxy that say that this source IP tried to go to this domain at this time and go to 403. But they have millions of those entries, right? But to log that entry, the proxy logs, to put in, there's a column called IP address. So they know they want to go to something crypto.evil domain, but there's a column called IP address. So the proxy will do an NS lookup of that URL, just to put the IP address, if there's any. And essentially what the proxy is doing is sending via DNS the crypto to me. Thanks, proxy. So WPAD, similar exercise. Again, I just query the DNS server for the wpad.company.com if it exists. Many people still use it, but it's going down the path. So the most common is DNS guessing. So what that means is companies use GPO. So that means that the profiles get pushed, the proxy URL, the pack file URL in the Internet Explorer is get pushed by GPO, AD profiles, right? So AD group GPO pushing that to users. So the only way that I come up with that is to find that proxy pack, proxy server, your name. So I generate the list maybe with 15 words like proxy, PRX, ENET, GW. So you generate a list of 15 or whatever you want, names, and I will make a dictionary, combining together with the dash, with the underscore, back and forward. So I will generate a list of using 12, I will get 250 entries, possible candidates. And I will query the internal DNS to see what actually reply. Whatever reply, I will try to connect to see if it's a proxy pack. If it's a proxy pack, great. If not, keep trying. So this is the the three proxy technique to exfiltrate data is the same. This is just a way to try to find the proxy in the company without having the GPO logins. And the last one is wireless exfiltration. In this concept, what I do is you do need proximity. You need to be close 100 meters or less, to be honest. But what I do is I do beacons or an SSID specifically, and within the beacons of this is a common Japanese brand of home routers called from NAC, a term. So you will see those tend to have 4 or 6, sometimes EXA, which is the last MAC address numbers of the router. So I'm taking the opportunity to put my crypto, which is EXA of the data, within those names. So first I send a beacon one to tell my device that my wireless device, Howler, to tell them, listen, I'm going to send you something. And I send beacons because beacons do not come up in the WIPS wireless. They're not actually access point. It's like your phone is beaconing from your home wireless, but you're in the office, so definitely not connecting. So there's a lot of noise on beacons. So that's the reason wireless IPS don't actually log beacons. And insert the beacons, send the beacons in short bursts, and then disappear. And change the beacon by a different SSID name. So far, any questions? Wow, impressive. Everyone understood or nobody understood? So that's it. There's free stickers for everyone. Thank you for listening and hope you enjoy it. Thanks.